Welcome to my topic on duct tape DevOps, a Fabric journey where I'm going to be talking a little bit about the experiences I've had with getting Fabric up and running, stable, and quite a few lessons learned along the way. Keeping in mind, because I am covering quite a few topics today, it's not going to be demo time. So this is really talking about the nuts and bolts, the insides. I'm not going to be diving into demos, and mainly also because most of this is actually talking out of a real world project that we did here in Switzerland, and presenting the customer's tenant is sadly not something I'm privy to do. So let me tell you guys a little bit about myself. So my name is Alex Dean. I'm currently head of data analytics at Allgäuer Schweiz in Switzerland. I've been a Microsoft certified trainer for 15 years, so I've been in the business of teaching and sharing my knowledge and helping people actually gain skills and lots of technical areas for quite some time. And the moment Fabric came out, I was in love. Seriously, when I saw what Microsoft was planning to do with Fabric, I thought, oh my God, this is so going to change the game. So yes, I am a Fabric fanatic. I admit it. I'm deeply in love with that platform. It is a love-hate relationship. Don't get me wrong. There's a lot of things to hate, especially when they don't work, because it's still in preview. But it's improving on a daily basis. There's new features coming out, exciting new features coming out on a monthly basis. And I'm pretty sure I'm going to stay a fanatic for quite some time longer. The topics today that I wanted to share with you guys drive out of a real world implementation we did. The customer is called Thommen Group here in Switzerland, and they came to us with a simple proposition. We have our reporting on a SQL data warehouse that runs every single night for a couple of hours to build it using SSIS scripts. And we've got Cognos reporting on top of that. And what we really want is a modern data warehouse with Power BI. And we went, hey, we've got the right solution for you. This was back in May, or beginning of June, not May. How about we do it using Synapse as our cloud data platform, serverless, and we use Power BI as our front end, and it's marriage made in heaven. And then Microsoft comes out with Fabric. And we all jumped into the cold water. This was virtually starting the project in August. Fabric was just a month old, and we started migrating on-premise data warehouse, on-premise BI to a brand new Fabric environment. So here's a couple of lessons that I'm sharing with you guys along the way. The first one is using the metadata-driven orchestration. That's not our idea. That's been around for some time, actually. The Microsoft team has got some really good content on that. And a person called Gene Hayes, who I became a big fan of, wrote a phenomenal blog post back in July about how to do metadata-driven orchestration in Fabric. So I will show you how we managed to implement that. Second up, I want to talk a little bit about capacity management. It's a topic that always frustrates because it's hard to actually figure out what capacity do I need. And it's going to be an important aspect for a Fabric engineer to be able to tell the customer or the boss how much money is this whole thing going to cost. So a good point. We've got Q&A as well. So if you have any questions, throw them in the Q&A, and I can try to address them at the end of the presentation. Next up, DevOps. So here we go. And we discussed with the customer how to build a stable cloud data warehouse solution. And Synapse has everything you want. It's got Git integration. You can use it with Azure DevOps pipelines. It generates a publishing profile that you can just publish to production. And it works. And we had already done it a couple of times in the past. We're quite experienced in it. And then we went, how hard can it be in Fabric? It's hard because especially middle of 2023, there was virtually nothing working DevOps-wise. By now, that game has changed. So I'm quite happy I can do this presentation today, a year later. because we do have quite a few DevOps options. And I will share with you some ideas on how to design dev test prods, how to split the different workloads, because you might have different strategies for different artifacts. Having DevOps for a Power BI report might have a completely different frequency and workflow than doing DevOps for a complete data warehouse with 160 different views. And then finally, a couple of design principles on workspace design, tying a lot of these things together, tying together capacity considerations, tying together DevOps, and also the metadata-driven orchestration all flows then into how do you design your workspaces within Fabric to be able to then go ahead and have a clean, stable prod environment. So let me get started with metadata-driven orchestration. So this is the concept that Gene Hayes came up with, and it works like an absolute charm. The idea is on the left, you've got your sources, your databases, where you've got your ERP data or your CRM data, the stuff you want to have in Fabric so you can start analyzing on it. So you're going to have pipelines that copy that data using the copy activity into, now your choice, a Lakehouse or a warehouse. Little tip, Lakehouse, really high performance, great for copying data into. Then you want to transform that data somehow. You want to make the raw data fit an analytical workload. So you want to think about how am I going to create a star schema? How am I going to maybe add type 2 changing dimensions and handle data changes adequately? And that's where the silver layer comes in. So we're using a medallion architecture here. Bronze is my raw data. Silver is my transformation layer. And then finally, gold, that's my presentation layer, where we're going to then have a beautiful star schema data set, or rather tables that have high performance using the direct lake capability. Now, in our case, we had a grand total of nearly 300 tables in the ERP system. And of those, we had 160 that were very interesting to us. So we had 160 source tables. On top of that, we were migrating the system pretty much as is. The goal was don't reinvent the wheel. They've got all the business logic and years and years and years of business logic built up. Can we migrate that in one batch? Built in SQL Server on SSIS packages? And the answer was yes. We were able to build a warehouse to host, hold your horses, up to 600 views. It's a lot of views. So effectively, every table that was there had, on average, 2 to 3 views that would then transform the data and fix primary keys and fix relationships and change data types. 600 views in a warehouse to be able to get my raw data into star schema that could be used for semantical analysis. You don't want to create 600 copy data tasks. Seriously, guys. Nobody wants to do that. And this is why the orchestration, medallion orchestration designed by Gene is really, really good. Because what you have is this orchestration database at the top here. This orchestration database effectively describes which tables am I going to copy and what is my destination. It's just row by row by row describing source, target, source, target, source, target. And you can use that to define your sources into the bronze layer, but you can use the same structure to define which bronze tables am I now going to transform using which views into my gold layer. So now we've got roughly, I think, 150, 160 different lines in this orchestration table that we can just pull up using Fabric pipelines. So the Fabric pipeline goes in, says, look up all the different transformations I want to do now. Only show me the ones relevant for the bronze layer, and I'll do bronze now. Show me all the ones relevant for the silver layer, and I'll do the silver layer next. And we're using a metadata-driven approach. Instead of having 100 pipelines, we create one that can handle that dynamically. Hey, thank you, Andrew. So that's the link for the metadata-driven pipelines. I'll also share a link at the end to, actually, I might be able to copy and paste for my presentation for you guys. Give me a second. So Andrew's already copied that for me. Thank you for that link. There's another really good link as well while we're at it. The Microsoft team put everything into a GitHub repo, which is a very, very good location as well. So why is metadata-driven approach so cool? Effectively, you can create all the tables, all the bronze, silver, and gold from one single pipeline. Now we create an orchestration pipeline, which means I'll first do my bronze tables, then I'll transform them, then I'll put them over to gold. And depending on how complex your data is, you might have even dependencies. So you might need some data pre-transformed before you can do the next step. So that's where the orchestration comes in the pipeline, and you just daisy chain your steps to be able to get at the end to a full load. It really makes it easy to implement that medallion architecture because you just segment your tables. You segment what you want to do. This first 20 statements is my bronze layer. The next 30 statements is my silver layer. And it makes it easy to then go through those layers and do the transformations. And it supports pretty much anything. So for this customer, we're using SQL concepts. So we're saying my source is a table, my source is a view, or my source might even be a stored procedure. The source could also be a statement that you're executing. For another customer, we're currently building the same construct where my bronze layer source is actually the table of an SAP table that gets triggered via Theobald. So I'm actually not using a copy data activity. I'm triggering Theobald Universal to extract and the SAP data into a data lake, and then we copy it over in the silver layer, and then we start working with it in the pipelines. So it's very flexible how you want to deal with it. It doesn't only have to be SQL. The source could be anything you want. So the GitHub repo already posted the link to that. And that's a great starting point. So that has got effectively all the source code you need to get started. It's got the source code for you to create your own orchestration database and fill it up with some dummy data. It's got, I think, AdventureWorks as an example from a data source, so you can start playing with it and getting a feel for how do I structure my my orchestration table, and then you can start building your pipelines on top of that. So here's the thing: storing the metadata in a Delta table instead as against in a SQL database. And notice how this metadata orchestration database is sitting outside of Fabric. The metadata actually isn't sitting in a Fabric warehouse or in a Fabric Lakehouse, that's Delta. It's sitting in an Azure SQL database. Now, when Jean created this and posted about this, she didn't actually tell me why she chose that architecture. I wish she had, because when we first did this, we actually took the orchestration database and put it into a warehouse and said, well, it's the database. You know, a warehouse can handle insert statements and update statements. We just put it in the warehouse. Why not? Little tip, don't do it. Warehouses, still today, in Fabric are designed for analytical workloads, big data workloads, tens of thousands, hundreds, millions of thousands of records. Primary keys, don't even try to go there. So effectively, if you're going to also be doing updates to a row, if you're going to be creating transactional workloads, it's not going to work. We had deadlogging problems, we had locking issues, we had timeout issues. But until we fixed it, I wish we would have just gone and said we create an Azure SQL database. So my tip, stick to this design. Your metadata-driven orchestration database with an orchestration table with the metadata in it, also where you might write back, when was it last updated, how many records did I pull out, any kind of statistics you want to record, do that in an Azure SQL database. Don't do it in a Lakehouse because you're going to updates anyway, and don't do it in a warehouse because you will get into performance issues faster than you can imagine. get started, metadata-driven orchestration, great for hundreds of tables and hundreds of views. Now, let me talk about capacity management. And depending on how much time we have on questions and answers, I might even pull out a couple of screenshots. Capacity management. Here is in a screenshot, yeah, a specific one that I sanitized from the customer. The most important tool to figure out how big a capacity you need is the Fabric Capacity Metrics app. And they tend to update it once a quarter with a couple of new features. The thing to understand is there's a magic number. Everybody write this magic number down. It's 86,400. Anybody know what that number means? What is 86,400? And I'm not talking about 42. Now, it's how many seconds there are in a day. Thank you, Greg. That's an important number to understand because in the end, everything is calculated by capacity unit seconds. How long did this job take? It took 10,000 capacity unit seconds. Did it take 10,000 seconds? No, it maybe only took 3 minutes. But it took, in those 3 minutes, 10,000 capacity unit seconds. We can take, for example, this one here, this job here, which was a Lakehouse job, used up 24,000 capacity unit seconds in 39 seconds. So, yeah, in 39 seconds. So quite a few capacity unit seconds packed into a very short period of time. What does that mean from a performance perspective? Microsoft will give you heaps of performance. Even if you've only got an F4 or an F8, it'll give you heaps of performance. It'll give you the equivalent of an F64, even higher, for a very short period of time. And then it's going to calculate and go, okay, so you've got an F8. I've given you enough capacity units for, let's say, an F100. It's going to now take you X amount of hours or X amount of minutes, depending, to burn down that extra capacity I've given you. And what it does is it uses a 24-hour averaging calculation. How much capacity do you normally use in 24 hours? And I'll start using that as a guiding principle on am I going to go over or not on how much capacity I've just given you. And depending if I've gone over or not, it might then start thinking about throttling the experience or maybe even rejecting requests. Looking at this specific screen here, we can see we've got quite a lot of spare capacity. So this is an F8 that we're looking at right now. And the F8 is hovering down here less than 50% of 100. So we're sitting at roughly an F3. Yeah, 3 of the 8 capacity units are being used. And once in a while, the red ones will bump it over. Now, when this happens, once in a while, there's excessive usage. Interactive, which means a report was executed or very large ad hoc SQL statement was executed. Fabric will give that statement all the capacity it needs, and then it's going to burn it down. So that's where this little chart here on the right comes in. It'll create an overage and say, okay, I've given you way more capacity than you actually have, but for the next couple of minutes, you're not doing anything anyway, so I'm going to burn it down. The blue bars here are just burned down, so I'm just going to start using up or recrediting you to your capacity. And then it's happening again, and I'm going to recredit you again. The goal is that this line at some point in stage pretty soon lands back at 0 again, and you're not in the overage environment. So you get heaps of performance, which is awesome. So it doesn't matter if you're sitting on an F4 or an F64, it'll feel really fast for a very short period of time. And if you're on a big capacity setup, it'll keep on feeling fast. If you're in a small capacity setup, you'll start to feel the pain pretty soon afterwards. The first thing it does is overage protection. So it'll allow you to do it and give you the overage without necessarily causing you any harm. Then it's going to start delaying. So if an end user now wants to run a direct query report, it might suddenly take 20 seconds to load the report. And if you've used too much, it might even reject those. And then right at the end, if you've really gone over background rejections, that means you can't even refresh the data set anymore. You can't even run a pipeline anymore because you've gone over your quota. So these are a couple of numbers to keep in mind. If what you're about to do now, a Python notebook running a machine learning algorithm, is going to use up less capacity units as you have actually available to you in the next 10 minutes. So if I'm on an F8, then it's effectively 8 times 60 times 10. And if this job that I'm planning to do for you right now is going to take up more than that, then I'm going to move into the next stage. If it's less than the next 10 minutes, just do it. I'm going to execute it, I'm safe. If it's more than 10 minutes, but less than 60 minutes of usage, that's when I'm going to start telling your end users, nah, you've stretched the boundary a bit too far. You'll have to wait. And then if it's more than 60 minutes, but still less than the capacity I still have available for 24 hours, then I'm still going to let the background jobs run. I'm not going to touch the background jobs, but the front end, no, you can't do anything. You will get nasty error messages, execution denied. Please come back later. And sometimes it says, please come back in 86,000 seconds. It's like, yay, come back tomorrow. Thank you. And finally, if what you're just about to do is going to take up more than 24 hours of the capacity that you've allocated to that workspace, it'll effectively tell you no chance, background rejection won't work. I have not found a way to pre-estimate your capacity. Best way to do that is get a trial, which gives you an F64, which is heaps for most initial workloads. Start running on that F64 and start analyzing the report to figure out how much capacity you're using, especially because different things use different capacity differently. So now we've just been introduced with AI skills, and they suddenly use capacity up in a certain way. Pipelines use capacity up in a certain way. Data flows use up a lot of capacity. So we've actually stopped using data flows Gen 2 because we found return on investment from getting the job done compared to a pipeline with a copy data activity wasn't there. So we much prefer copy data activities and SQL statements than data flows, although data flows are so nice and fuzzy and Power Query, and any Power BI lover loves them too. They were too expensive in the end. So pipelines were better. And yeah, you'll have to try it out. Use a trial capacity and trial and error, run that report to figure out how much you're using and then work your way backwards. Okay, good point by Carl. Yeah, I'll just quickly inject that one. If you're running a Power BI incremental refresh, so you're not incremental, import mode refresh, so you're loading all the data into your model, that is counted as a background job, not an interactive job. So that fits into your background activities. And if that's still within the limits of what you have, all the front-end requests against that report cost nothing. They won't even have a blip against your capacity. So yes, once in a while, that might be a good solution to this. But then, of course, you lose the direct lake capabilities and being able to play around with big data. So it all depends on your use case. A couple of things to keep in mind. If you know that your end users are going to get nasty error messages if the capacity is being throttled, you don't want that. You really don't. So Microsoft's recommendation actually is to separate your front end and your back end capacities. Don't buy one, buy two. Have an F4 for front end and an F8 for back end. And then actually, you might even get away with an F2 for front end and an F8 for back end. And make sure that the front end jobs don't rely on the back end to work. And in that case, you can have your front-end activities without necessarily the same throttling and pain that you would get from your back-end jobs. So if you can separate them out, only downside, of course, is if you're going to be buying 8 F8s, you don't get all the features of an F64. The F64 comes with a whole bunch of features that you only get if you buy at least one F64. And if that is going to be the Copilot feature, or previously that was private endpoints, and thank God they've now made that generally available to everybody. But there's always like AI skills. That's another F64 only feature. You only get that if you actually buy at least an F64, and you might want to split that across multiple workloads. Because if you're doing 2 F32s, you actually don't get that. Something else to do is autoscale. So that's what we're doing for our customer, especially down to Carl's message around import mode. We figured that out as well. And what we're doing is we're scaling up the front end workspace using automation in Azure. So you can create an automation account in Azure. We're writing a PowerShell script that then effectively scales up the capacity, then runs a refresh, and then scales it down again. Using this autoscaler has two benefits. The first one is the capacity scaling really only happens while the refresh, because we're polling the refresh and making sure we know when it's finished so we can scale it down again. It gives us extra memory. So our core models are so big that we need an F64 just to load it and refresh it because it's so memory hungry. But once it's running, it's smooth sailing. So for half an hour every single day, the workspace is running on an F64. And using an autoscaler, you can actually do that quite nicely. Please monitor capacity usage and make sure you stay below 80%. That's the 80-20 rule here, fits perfectly. That'll give you enough air for interactives, will give you enough air for overage. And as soon as you're getting over that 80%, you will notice that too many interactive overages might start throttling and might actually start causing a degraded behavior. No, Glenn, you can get a trial more than once. So first up, you can extend a trial at least once. And secondly, you can have up to 5 trials in your company. So here's a little tip. Switch off the ability to create trials. So not everybody does it straight away. And you might still have 1 or 2 options available. You can always hook up the workspace to somebody else's trial later. So you have a bit of flexibility on how many trials you can actually use before you have to commit a lot of money. Next up, real-time KQL. Word of warning, we love the real-time features. We've created some really cool real-time dashboards for our customer that they never knew they could have before. Straight from the logistics center, from the call center, planning deliveries, planning pickups. All of that is now in a real-time Power BI dashboard. Brilliant. We need a KQL database to be able to handle that. Easy. Fabric, 2 clicks, you've got a KQL database. But just to keep the database alive costs just over 1 Fabric capacity unit. And that's just keep alive. That's just keeping it humming along without even having lots of data in it. By now we've realized we're actually closer to an F2, just to run a KQL database. So while it's cool, be careful. Things cost money in Fabric, and real-time costs money too. So what we did for our customers specifically is create a charge-out structure. So it also helps us go into the domain of data mesh. So data mesh is a beautiful concept where different business units create their own data products. And effectively, they even share the data products and can reuse data artifacts from other places as well. And Fabric really brings us to that dream. I would say a year ago, it was a pipe dream. By now, more and more organizations are seeing how they can create data mesh architectures using Fabric. And because you can easily say, logistic team, you're going to get your own F2 capacity. I'm going to hook up your workspace with that. I'm going to charge you back exactly what you use. It makes it really nice for an IT manager to create different charging models and still enable a centralized software as a solution platform with a distributed data storage. And by the way, Microsoft didn't think of this. I personally believe the one that really drove that message home was Snowflake, because Snowflake came up with most of the ideas that Fabric is built up on today, having separate data storage, being able to separate the data layer from the compute layer, and also being able to charge out compute layers to different business units separately and give each unit just as much compute as they need. Snowflake designed that from the start, and Microsoft just copied from their book. Yes, and yes. So I'll talk about data sharing at the end, specifically on how to share artifacts across workspaces. So I'll get you an answer later in this presentation. Talking about capacities, you want to reserve your capacities. So it's 40% cheaper. Yeah, so it costs 50% of a pay-as-you-go. So definitely want to look at reserving that and pre-booking that capacity, but careful. You have to plan this well in advance. Any unused capacity, it doesn't carry forward. It's not like frequent flyer miles that you can use up later. They just expire at the end of the month. Interesting though, you can buy them in increments of a single capacity unit. So you can't buy one F12. It doesn't exist. It's 4, 8, or 16. But you could buy 12 capacity units reserved. And then based on those 12 capacity units that you've reserved, you then activate an F4, another F4, and 2 F2s. And then you're at the 12 effectively that you're using up. So it becomes flexible on how many capacity units you can buy and then use them. Anybody that buys 13 is insane because you've just wasted money. If you use auto-scaling, like I described it earlier, I'll bump up my capacity from an F4 to an F64 and then take it down again. That extra half an hour where my total capacity that I was using assigned to all my workspaces was above my reservation, that gets charged at pay-as-you-go rates on top of your reservation bill. So if you've reserved, let's say 10 capacity units or 12, don't expect to see $1,000 at the end of the month, roughly, let's say $100 per capacity unit in reserved. If you're auto-scaling, then you'll have 1,050 or 1,100, depending how much auto-scaling you're doing, to cover that extra peak that you've gone over the reservations. And the second to last, that's a very important thing you'll have to understand. And I've seen one of the other partner who learned it the hard way. There's no way to cheat the system. If you have a job that uses massive amount of capacity units right now, and then you've got throttling and you've got rejections and it's really slow and you go like, oh my God, I just need capacity for my users. If you stop the capacity and start it again, the slate is clean. Or if you delete the capacity and create a new one again, the slate is clean. And no throttling and no rejection, and everybody's happy. But what you'll notice at the end of the month is that all the excess capacity that you had used and that you had decided to shortcut and not wait it out over the next 24 hours, but shorten that cycle to in the next couple of seconds, that gets charged the instant you turn off that capacity. All the overage, all the capacity unit seconds that haven't been burned down yet, that haven't been carried forward and smoothened out yet, they get charged instantly. So be wary, don't do it. You might get some really nasty surprises when your bill arrives of, hey, I reserved an F8. Why is my bill 3 times the price? Well, because you kept on stopping it and Microsoft kept on charging you the extras. And something else to keep in mind is a reserved capacity doesn't include any extra storage costs you might have in the OneLake storage. That gets added on top of your Azure bill as well. Okay, now then, 2 more topics to go, halfway through. Duct tape DevOps. So I'm a huge fan of DevOps. I like to have my production environments running stable. I hate working on production, and whenever I can, I will force my customer to take DevOps seriously. So when I started thinking, how can we do DevOps on Fabric, I panicked. It wasn't easy. But by now, I've got what I call the Trinity of Fabric DevOps. And this holy Trinity is made up of 3 different ways to do DevOps. On the one side, I've got the deployment pipelines. Some of you might know them already. Those are Power BI premium features, been around for quite some time, been pretty cool actually, where you can, in Power BI service, define dev test prod, define a pipeline that then moves your artifacts, your Power BI reports or your semantic models between the different environments. Really cool feature. You can even replace parameters or replace connection strings. So in dev, I actually look at the dev database, and in test, I actually look at the test database. And this has been evolving to maybe one day become the only primary way of doing DevOps in Fabric. But it's not quite there yet. It's not there yet for a couple of reasons. The first one is I can't do as many replacements as I would like. I can't replace things in pipelines right now. But if I've got a pipeline in dev that's looking to a specific database, and I want that pipeline to look at a different database and test, there's actually no easy way to do that if the artifact I'm looking at is outside of the workspace. If it's inside of the workspace, it actually handles it quite nicely, like a bit of black magic, and it replaces those pointers for me. But if what I'm looking at is outside, it doesn't work that well. And on top of that, at the time, like even 6 months ago, lakehouses were kind of supported and warehouses weren't. So to get a warehouse fully designed with all these views and stored procedures and functions from dev to test to prod, there wasn't a good way at all. Now, since June, they've introduced warehouse support, but it's still buggy, very buggy. Still doesn't work for our customer. So here's the third option, DAG pack deployments. With DAG pack deployments, been around for years, eons, and create a SQL database project, either an Azure Data Studio, Visual Studio Code, or Visual Studio if you want. I create a DAG pack, it's a deployment artifact, and then I can deploy that to a target environment. And the way the DAG pack deployment then works is it compares the schema and the DAG pack with the target, creates the delta and says, okay, now I will apply the delta to the target environment. Works like a charm with SQL Server databases. A little bit trickier with Fabric warehouses. While at the surface it's supported, Fabric warehouses and lakehouses do not support the alter table statement. So if you've added a new column to the table, the DAG pack deployment will want to create an alter table statement and execute that and say, yep, just add a new column. Doesn't work in Fabric. So you'll have to take a couple of step backs, a couple of workarounds, and figure out how to do this with the least amount of tables in your warehouse. Maybe better create views, or maybe only have temporary tables that you're going to throw away and then recreate, and definitely not have any tables you want to permanently keep and keep on changing, because it becomes a bit of a nightmare to do that. It's not impossible. You can still do it via Python scripts, but DAG pack deployments are then not your tool of choice. Now, the thing in the middle, the branch-based deployments, that's actually the deployments that we've been used to from the days of Synapse. All the changes that you do are checked into Git, source control. That's a premium feature. So any change to a pipeline, any change to a notebook, or even addition or removal of a lakehouse, that is added to your Git repo. And you can then say, I've got, this is my dev branch, sitting on my dev workspace. Now I'm going to create a test branch sitting on my test workspace. And to get my changes from dev to test, all I have to do is a pull request. I merge my changes in Git from my dev branch to my test branch. And then I go to the workspace and I say update, and it pulls the latest changes from the branch straight into the workspace. And it actually works really well. On top of that, by using branch-based deployments, we can do this quite nicely in Azure DevOps. So what we did was we also injected a little PowerShell script that does a bit of a replace. So we can now control and replace parameters. We can replace strings and connection strings within the pipelines, because all they are JSON, and fix up test and fix up prod, just the way we want it to be. So what worked for me in the end, we use all three in one go. We're actually using all three of them to create a deployment orchestration. So not only metadata-driven orchestration to get data into your Fabric warehouse, but also a deployment orchestration to effectively move from dev to test to prod. And one of the important elements here, you might see that at the bottom, is there's also a different frequency. I've got a bunch of BI developers and front-end analysts. They're making changes on a daily basis, and they want to be able to deploy every week. So they've got weekly sprints where they want to deploy from one environment to the next. Then I've got data engineers. They're working on adding new tables to my data warehouse, extending my data warehouse with new sources. Let's now add success factors. Now let's add Jira as a data source. So they're working a lot on the silver layer, but they don't do that weekly. They've got a monthly deployment cycle that they want to be able to say, every month I'm going to add new tables to my environment. And then in the middle, I've got the other team of data engineers that keep the nuts and bolts working, make sure those pipelines are working, the notebooks are doing all the cleanups and the maintenance jobs. And that's rare that actually changes happen here. Once you've got it up and running and you've got a really good orchestration pipeline, you don't make many changes to that, more like on a quarterly basis. So you got different speeds at which you want to make changes and move them through dev test prod. And we chose the one that really fit with the use case and the speed best. So we've got one workspace for the BI side of things, the reporting. We use deployment pipelines to move that through the stages. We've got a separate workspace where we've got all of our pipelines and notebooks and also Lakehouse artifacts in it. And those ones we tend to really only deploy on a quarterly basis. And finally, the warehouse, where there's a bit more action, that's on a monthly basis. And we use DAC pack deployments for that. So yeah, really separate those artifacts out. The workspace has got pipelines, does not have a warehouse in it, does not have a semantic model in it. Really separated them based on type. And that's helped us keep the deployment process clean. And on the one side, we've got Azure DevOps, keeping it together. That's a bit of duct tape we've applied to this process to create release pipelines that will automatically execute the PowerShell scripts, change the parameters and the connection strings, generate a new branch, also all done by Azure DevOps PowerShell scripts. Then I've got a separate pipeline to deal with DAC pack deployments. And there's also manual processes in between because sometimes you need data. So one thing we're not actually doing, and this flows back again to the metadata-driven orchestration. One thing we didn't do is create 160 schema definitions. We didn't create this whole solution schema first. What we said was, here's a source table, do select star from the source table, here's a destination, just all I'll do is give you the name. And it actually creates the schema on the fly, which is so comfortable from a deployment perspective, so comfortable from a getting data into your Fabric perspective, and so dangerous from a DevOps perspective. Because if your silver layer needs a table to be able to create a view, because I've got a dependency, If that table doesn't exist, the view is going to fail. Deploying the view is going to fail. I can't deploy a view to my warehouse if the table it's pulling doesn't exist. So that's why we still have some manual processes in here. If there's new data being added, we actually first have to execute the bronze layer. We actually have to get the data into the Lakehouse before we can then do the DAC deployment to create the silver warehouse. So there's still some manual processes, some extra duct tape that's holding this construct together. Looking at deploying resources, as long as the Fabric API cannot be executed by a service principal, we're not quite there yet. So you can execute Fabric APIs with your own credential. Like if I log in as Alex Dean, I can execute the API endpoints, the REST endpoints, they work for me. Same thing when I say, hey, Azure DevOps, or please now execute a Terraform or execute a Biceps and create things for me using a service principal, it doesn't work yet. Once that's been fixed, really interesting scenarios for creating everything code first. So that'll be interesting. Hopefully coming soon. It's on the roadmap. Service principal support is on the roadmap. The moment it is there, yes, we'll be able to finally automate a lot more and even be able to get to infrastructure as a code, which I'm sure quite a few of us are really interested in. So last topic, 10 minutes to go. Oof. I warned you, I'm covering a lot of content. Workspace design. So this is an important element to now think about, because going back here, already, you might have noticed, there's a certain amount of design principles flowing into this part. I'm going to have my semantic model separate from my warehouse separate from my pipelines. I'm going to have different ways of deploying these things. So all of this will already start implementing or impacting how you're going to design your warehouse workspaces. So one thing at the bottom that you might see, one piece of duct tape that holds everything together is we have Git repos for everything. So even the BI space, where we've got Power BI semantic models, even there we've got a Git repo sitting behind it. So every single workspace in Fabric is hooked up to a Git repository. That's important. You want that source control, you want that rollback capability, and you also want the extra benefits you might get for DevOps. But then we've split it up into 3 separate workloads. We've got the ETL workload, pipelines, notebooks. We've got the warehouse workload, silver layer, transformations, and we've got the BI workload. And when I'm now thinking about where am I going to add my Fabric capacity, am I going to buy one big F16? I'm going to buy smaller ones. This is where you also want to start splitting up your front end from your back end. So here's an example. The ETL and the warehouse workspaces, they sit on an F4 reserved capacity. And then the front end, well, they sit on an F4 capacity, and the front end that also sits on an F4 capacity. And this way, you've got 2 capacities, but you can share one across multiple workspaces. You don't have to have a capacity per workspace. You can have 10 workspaces hooked up to one capacity. So here we've got 2, ETL and warehouse on one, and then the front end on the other. But here, this is for prod. This is my production workload. Go one level deeper, and we also have to think about dev and test. So for dev and test, and we created 2 separate workspaces each, we're using ad hoc capacity scaling. So the idea here is we've got an F2 just humming along, holding the pieces together so that nothing gets deleted, because as soon as the workspace doesn't have an active capacity, Microsoft will start deleting things. And then when we need to ramp it up, when we've done some development, we now want to run a whole pipeline again that takes up a lot of capacity. It takes up 24 hours of F4. Then we ramp it up. We say, okay, I'm going to ramp this up to an F8 or an F16, depending on how much testing you're going to be doing. And I'm going to run that for a day on a higher capacity. And then once my testing is complete, I'll take it down again and keep humming along on an F2. So dev and test, they don't have to have massive capacity the whole time. You tend to do data refreshes more infrequently, not daily, maybe once a week. You might be, though, running the pipeline 4 times until you're happy with it. So you'll ramp up your capacity when you need it, and you take it back down again. That's still a manual process where the developers and engineers have to actually consider, what do I need? And just keep it humming at an F2. So that ends up with multiple different workspaces. So in our design for this customer specifically, we've got 9 workspaces, 3 dev test pod for the ETL, 3 dev test pod for the warehouses specifically, mainly also because we needed to separate them out from the rest because they kept on crashing our branch-based deployment, and 3 dev test pod for the BI workload, because again, we can do much faster DevOps deployments using the deployment pipelines built into Premium. And then again, different capacities you assign to each. Looking at some security considerations. So now this is again where we start talking about sharing data. Yeah. Only the engineering team gets access to dev and test. End users don't get access to those environments at all. The majority of staff gets access to an app that we publish on the BI prod workspace. So the front-end prod workspace app on top of that, that's what the majority gets access to. Read-only access to the data, slice and dice, play with it, get your insights, but that's where the buck stops. Now we've got power users within the organization. Often you'll find them sometimes in logistics, sometimes in finance. They will get access to the semantic models. They get BI, what I call BI self-service, and they get build access to the semantic model in BI prod that allows them to analyze in Excel, that allows them to create their own reports from it. And there's an extra layer, and that's becoming more and more interesting. And this is now where you, for example, have a data scientist or engineers from other teams. They can then also get access to the data itself, to maybe a lakehouse specifically to run elements against. And this now, you can either do, and that's the question from Virendra, with shortcuts to lakehouses in the pod. So in one case, the way we solved this was that team, in this case, it was the marketing team, they got their own lakehouse and their own workspace, and then shortcuts to the different tables that they needed so they could work in their own workspace, create their own semantic models, create their own reports, and the shortcuts then gave them the tables that they needed without giving them full access. Not because they weren't allowed to have full access, more because it was easier for them to have a bit of tunnel vision and only work with the bits that were relevant to them. You could also share a lakehouse using the sharing link. I personally am not a fan of sharing links. You lose overview, it's hard to audit and maintain, and suddenly too many people have access to the lakehouse. So I'm not a huge fan of that. I much prefer to say, hey, I'll create you a lakehouse. I create shortcuts to the tables you need. Have fun. It's now yours. Which changes in the shortcut lakehouse affect the data in the origin lakehouse? Yeah, but from that perspective, make sure that these people only have read access. Otherwise, yes. I haven't tested that out. They're only using read access on that right now. Sharing tables in a warehouse. You can create shortcuts onto a warehouse table. That's no problem. So you can have a lakehouse that shortcuts a warehouse table. That works. Just doesn't work the other way around. You can't create a warehouse that has shortcuts, sadly enough. But yes, you could create a shortcut in a lakehouse for that team to a warehouse table. That works. And I only got 5 more minutes. Create 3 data wares, 1 for each environment, dev test pod. Yes, I would definitely suggest you do that. Keep each one separate. That gives you clean DevOps to be able to populate each one separately. Yes, please do. Anything else in Q&A that I've missed? How did we implement autoscale? We used automation account in Azure, but logic apps also could have worked. Where can we keep our orchestration SQL outside Fabric? Yes, please, outside Fabric, Azure SQL database right now. There is something coming under NDA, private preview. So watch this space after the Fabric conference. It might actually get announced where there's a new thing you could do. Can't talk about it. Well, the metadata-driven orchestration, it's a concept, yeah. But yes, the Fabric product team is enabling things in Fabric to make that easier and to solve some of the problems that we had to find workarounds for. Okay, I think that's it, guys. I hope you enjoyed the session.